All right, so as we're starting the digestive system, the GI tract is the gastrointestinal tract. So that's where we go from the mouth all the way down to the anus. Now, these models only show the anterior version, but we clearly know your anus is not in the anterior. So it's going to go back, and I just want you to, I know that sounds silly, but we want to make sure what we're looking at a model versus real cadavers and material. So if you go into the oral cavity, you'll see the soft palate, then it becomes the hard palate. Well, it's the hard palate first where the bone is. And what bone is that? Palatine process of the maxilla. And then we have the soft palate that becomes the oral cavity or the oral pharynx. We have a muscular structure there called the tongue in our oral cavity. Then we see a few different glands, which are your salivary glands. Down here is the submandibular. Directly underneath the tongue is the sublingual. And on this side, kind of where the buccinator muscle is, or your buccal region, is the parotid gland. And just a little tidbit about the parotid gland. Mumps infects that gland, and therefore they look like chipmunks when they have mumps, because they look like they have some food in their mouth and they're storing it, but instead it's just a swollen parotid gland.
So is it right here, right next to the masseter?
Masseter.
Okay.
It's like in between the masseter and the buccinator, because those are like layers of superficial and deep, right? So then we're going into the oral cavity, into the esophagus, which you can't see up here clearly, but you could see it posterior to the trachea, which is why we said the posterior side of the trachea did not continue its cartilage rings, because of this tube that has food when you're eating or swallowing, going through it, so it has room to expand when it does that. Well, this tube pierces the diaphragm, and off of that hangs the stomach in that fashion right there. So where we enter into the stomach is known as the cardiac region. And the sphincter itself is like a structure that can close or seal off this region. And that sphincter is called the cardiac or the lower esophageal sphincter. Okay? So the stomach itself kind of looks like, I say J because you're looking at it this way, or C, whatever works. This is the lesser curvature. This is the greater curvature. Well, if I open this up, you would see that there's a clear folding distribution within it. And some people eat this. It's known as tripe. Do not write tripe on your test, because tripe is food. This folding is called rugae, R-U-G-A-E. And it's very close, it's very similar and called the same thing in the urinary bladder, still rugae. But these foldings do what? Expand, increase surface area. Anytime you see folding in anatomy, the reason for it is to increase surface area. So let's think of it this way. If you had an accordion, everybody know what an accordion is? The thing that like fans out and it becomes really small. How do you put it back in your case if it didn't have folds? Wouldn't that be a huge case? So it increases the surface area as we expand it out, but it can also, it's because of those foldings that it had. And right when we get into the stomach, this region here is known as the fundus, which is similar to the same term that is used for the uterus as well. So the fundus is the initial opening. That's usually the wider portion. Then as we get to this region here, kind of midpoint, that's known as the body of the stomach. And then down here, I'm going to close this guy because internally I was just showing you the rugae. Now, for test purposes or lab practical labeling purposes, if there is a structure about the stomach I want to ask, I will probably name it on the outside surface, the exterior, as opposed to here knowing that this is rugae is what I want. Does that make sense? So just to eliminate some confusion on what I'm trying to label. Down here is the pyloric region or the pyloric sphincter. And this empties into our next structure on our pathway, and that is the small intestine. So now you can see the pyloric sphincter kind of there as well, because we kind of showed it in both regions because it would attach like that. Okay? So food is continuing to move here, but then that region particularly is called the duodenum. So the small intestines is actually about, and don't quote me on this, 30 feet approximately. So if I were to take all of the intestines out, it would be that big. So there's a lot of foldings. Once again, why are we having foldings? Increased surface area. You guys are good robots, by the way. It's great. So you'll see that there's this adipose-like structure right next to the small intestine. And if I took the stomach out, it's directly really attached to the greater curvature of the stomach. And that organ has a head, body, and tail, and it is known as the pancreas. How do I know that? Because no other structure looks like that, really, in that area. We have the duodenum. In the middle, a majority of the small intestines is this structure, and it's the jejunum. And the very last portion is the ileum. Now, the ileum, if I were to take all this out and show you a little more detail, this is the location where we start getting into the large intestine. Okay, so that junction right there is known as the ileocecal valve, because then the very next structure is the cecum. And you see this worm-like structure hanging out here off of that cecum, and that's known as the vermiform appendix. And you know, on our lab book, our last, I don't remember if I put vermiform or I just left the word appendix. So vermiform means worm-like, and appendix is an appendage, like an extra part. So there's that worm-like extra part right there, right? So this is cecum. Now this becomes the ascending colon. If I put this guy back on, right here, this is the transverse colon. This is the descending colon. And right about here, where it starts to curve, we call that the sigmoid colon. Now, on a 3D picture even, it looks like it's curved, but where do we end up having to go? Because where is this eventually having to go? Starting at our stomach, at our intestines, anteriorly, where do we have to go? We got to go posterior. So it's really not making an S in a way that's 2D. It's kind of like an S shape going to the posterior side. Okay? So the sigmoid colon, by the way, is the most common region for colon cancer. And why do you think that is? Because it's the only one that kind of curves and goes back. So a lot of crap, literally, gets stuck right there. And then I've just taken this guy off and followed that sigmoid colon to this region, which is showing the rectum. And then if this guy had even more anatomy in the back, that would be the anus or the anal canal shown there. I'm going to show you the accessory organs of, well, we did cover this pancreas. And once again, here's another version of pancreas. Still, what is this organ right here, Belle? This is the spleen right here. So it's basically attached to the spleen and the stomach. and it's directly underneath all of that omentum stuff. So on a dissection, it clearly just looks like adipose, and a lot of students mistake it for just being adipose. So it's your head, body, tail. Okay? This is the liver. The liver has 4 lobes, and it has on the posterior inferior side of it, excuse me, this green looking thing called a gallbladder. Okay? So if I were to put this in my body, it would be sitting like this. And most people are really surprised at how big the human liver is on a cadaver, or any animal for that matter. Like, it takes up a lot. So your liver, think your liver every day. It's doing a lot. So you can clearly see that there's different lobes here. This is on the right-hand side. The most right-hand side is the prominent lobe, and this is the superior lobe. This is also known as the right lobe. So right lobe, left lobe. And then when I go this way and I'm looking at the inferior side, I see a white streak right there representing the representing a ligament. This is your ligamentum teres. Ligamentum teres. If I were to outline this square right here, you would see it comes in the shape of a square. So this is another separate lobe interiorly between the gallbladder and that ligament called the quadrate lobe. Quad. You can see that. On the other side of it, right here, it looks like I could put my thumb there. And that is the caudate. Because what does caudate mean? Caudal. Cephalic was head. What was caudal? Towards the feet. So if I put it in anatomical position, it is the one pointing down, or the most inferior. So quadrate, caudate. And within here, you can see some vessels. This big chunk of a guy, which we already talked about in our vessels, what is that? The hepatic, portal, vein. Excellent. All 3 of you collectively would have got it right. So the gallbladder, and I believe this liver does just a better job of showing you the vessels. Another term for gallbladder is cyst, C-Y-S-T. So the vessel that drains from the gallbladder is known as the cystic duct, right there. The cystic duct and the hepatic duct, which is also known as the common hepatic duct. Because if you look really close, we have the other side of this green go into a right and left hepatic vessels. They both together, right at that number 5, create like a Y. You know, it's like they come together at that Y. That is known as the common bile duct. And that's your number 5 right there. And don't memorize the numbers, because I may just use, well, this guy's horrible, but a picture, so that's there. We don't refer to the veins and arteries because we already had a test on that. So you should know that. And I believe that was the digestive system.